This is a piece of raw quartz. Those tiny, glimmering yellow flakes are real gold, but they're trapped inside this solid, heavy stone. To get that metal out, we have to find a way to separate it from the rock itself. The first step is brute force. We have to pulverize the quartz into a fine sand. By grinding the stone into powder, we physically release those gold particles, so they're no longer locked away. Imagine this crushed rock in a bowl. It's a mix of ordinary sand, heavy glass marbles, and microscopic glitter. Here, the sand is useless quartz. The marbles represent coarse gold chunks, and that glitter is microscopic fine gold dust. Our job is to pull every marble and every single speck of glitter out of that sand. But we have to do it for tons of rock at a time, and we can't afford to lose even a tiny bit. This is the core of gold mining. It's not just about finding the rock, it's about the physics of separating the valuable from the worthless. Every speck we miss is money left in the trash. To handle this at an industrial scale, engineers use a method called the bubble trick. In the mining world, it's known as flotation. The crushed rock is mixed into a giant vat of water and special chemicals. Then we pump in air to create millions of rising bubbles. Chemicals make the tiny gold glitter stick to the air, hitching a ride on bubbles to the surface, while sand stays bottom. But heavy gold marbles are too dense. Bubbles can't lift them, so they sink and get lost with the waste sand. To catch those heavy chunks, we need the earthquake trick. This is a shaker table, a slanted platform that vibrates violently back and forth. As water washes the mixture across the table, the extreme weight of the gold marbles keeps them trapped against the surface, while the lighter sand just washes away. The bubbles catch the glitter, but drop the heavy marbles. The shaker catches the marbles, but lets the glitter wash away. Neither one can finish the job alone. Engineers combine these methods in order, starting with the heavy lifting. First, the crushed mixture is sent through a high-speed spinning machine. Think of it like the spin cycle on a washing machine, and then across those vibrating shaker tables. This initial step captures heavy marbles immediately, storing coarse gold safely. The leftover watery mud, holding microscopic glitter, is piped into flotation tanks. Bubbles sweep up the fine gold. Both gold types go to the same bin, while clean sand is discarded. By testing this three-step sequence, researchers caught the big chunks first and the dust second, recovering over 94% of the total gold. That's much higher than what we see when using just one method. We've come a long way from that solid piece of quartz. Getting the gold out is a journey of breaking, shaking, and bubbling. In the real world, every gold deposit has a different personality. Some rocks have mostly large marbles, while others are almost entirely microscopic glitter. A rock like A might only need the bubble tanks, but a complex rock like B, with both big chunks and fine dust, requires the full multi-step recipe to be profitable. This is why mining scientists act like chefs. They run small-scale tests in a lab to find the perfect recipe for a specific rock before they ever spend millions of dollars building a full-scale plant. If they choose the wrong process, they could leave millions of dollars worth of gold sitting in a waste pile because it was too heavy for the bubbles or too small for the shaker. When you see gold jewelry, you aren't just looking at a pretty metal. You're seeing the result of a perfectly executed, high-tech sorting act.